Stoichiometry. So, number 93. Compound calcium cyanamide can be used as a fertilizer, or cyanamide. To obtain this compound, calcium carbide is reacted with nitrogen at high temperatures. Blah, blah, blah. Here's where we get to the root of the situation. You have an equation they gave you. Yay, you don't have to write it. Double check that it is balanced. Test, does that one look balanced? Good, I agree. There's 1 calcium, 2 carbons, 2 nitrogen on both sides. The information they've given you is what mass of this can be produced if you have 7.5 moles of the calcium reactant and 5 moles of the nitrogen. The beauty of this question is they've already put it in moles for you. So, Will, you don't have to figure out molar mass of these compounds and go to moles. It's already in moles. All you need to do is compare it to the balanced equation. Or you can double check your answer by actually calculating how much product each of these would make. So I'm going to show you both of those ways. First of all, the book shows you right here the first way, which is you have a 1-to-1 ratio of these 2 reactants. Cade, they gave us 7.5 to 5. So who's going to be limiting? 7.5 or 5? 5. And who was only 5 moles? The nitrogen. So what's the ratio between the nitrogen and the product? It's a 1-to-1. So if I have 5 moles of that limiting reactant, I can end up with 5 moles of product. However, did they ask me for moles of product? They asked me for mass of product. So I will have to multiply by the molar mass of 80.11. Where did I get that 80.11 again? I added up all of the molar masses from the periodic table. Calcium was 40, carbon was 12, the 2 nitrogens, 14 each, so that's 48. 28 plus 12 plus 40 gives me 80. And that is how they calculated 401 grams of calcium, whatever this stuff is called, some crazy carbon amide, cyanamide. Cyanide does not sound like something I'd want to put on my fertilizer, but, you know. What's another way to do this problem? Another way to do this problem you will still have to use that molar mass at the end. Is that what you're asking me, Lauren? You don't need to use molar mass at the beginning. You don't need to go to grams. Mole, remember our handout that had the heart in the middle? What was inside the heart? Moles. We love moles. They're our friends. And if we can go to moles, we can go from there anywhere. We don't need to go to mass. They didn't ask me for the mass of the reactant. What if I want to double check my work by saying 7.5 moles of one reactant, the calcium carbide, and figure out how much product I'm going to make? What's the ratio from the calcium to the product, fertilizer? It's 1-to-1, isn't it? 1 mole gives you 1 mole of this. And so you could say I have 7.5 moles of product. It's a way to use your formulas, your equations, to double check that you've got the right limiting reactant in your hands. 5 moles of the nitrogen, using that mole-to-mole ratio between the nitrogen, which happens to be 1 mole, and the product, which is also 1 mole. Where am I getting this 1 mole from? Where am I getting my mole ratio from? Where do I always get my mole ratios from? From the balanced equation. And that would tell me I'd have 5 moles of product. Now I just look at it, which one's giving me the least amount of product? The nitrogen. And I only get 5 moles. They did ask me what the mass is, so I'd again have to multiply by that molar mass to get 401 grams of product. The only thing I will change is what's on the bottom, because I want to be able to cancel that reactant to get to the product. That is what will change. Good question. Others? Nikita? Correct. If they only give you 1 reactant, they'll either tell you or you assume that they have lots of the other reactant, and you only have to worry about the one. If they give you both reactants, you have to figure out which one is limiting. If you give you amounts, grams, moles, yeah, test. Could who switch? Could I have a different reaction that had a different coefficient that changed? Like when you looked at this at the very beginning, you saw that there were fewer moles of this, and so you figured that was going to be limiting. Yes, absolutely, Tess. If your balanced equation worked out to have a different relationship between product and reactant, then yeah, that could totally change this end result. Good question. And I think that's kind of a question Jenna was looking for too. If you had different mole ratios, it could change what was actually limiting. And I don't know if you guys remember, but last week that was a big issue. I remember Summer saying, hey, if I have the least number of grams, isn't that always going to be limiting? Okay, that was Gus. Hydrogen's really light stuff. You could have a very small amount of it and actually have lots of atoms of it. And that's why we have to go to moles, because it takes into account how much each atom weighs and just tells you how many atoms you have. Let's look at 98. I'm going to stop this one right here.